right, now that you've seen the formula for a Taylor and MacLaurin polynomial, we're actually going to do some examples where we have to create the polynomial. So at the end of this lesson, you'll be able to write a Taylor or MacLaurin polynomial for a function. All right, this first one, it says to find the Taylor polynomials for orders 0, 1, 2, and 3 generated by f at a. All right, so we're going to come up with 1, 2, 3, 4 different polynomials to model this function. And again, we're going to, and when we're done, we're going to draw a little picture so you can see what's going on with the problem. All right, so if I want to find the polynomial of degree 0, what I need to do is we are going to use that formula, and I'm actually going to write that formula. Hopefully you have it. The first one said to do f of a, so we're going to do f of pi over 4. So degree 0 means there was no x in the problem, so that's all we need to do. So if we do cosine pi over 4, so basically what we're doing, we're going to take the cosine function, and we're trying to find a polynomial function that would give us the shape of the cosine function if we went more and more degrees out. Okay, so we got cosine of pi over 4, and that is equal to the square root of 2 over 2. All right, so that was degree 0, order or degree 0. Okay, P1 would be the first, what we just found, it would be f of pi over 4 plus f prime of pi over 4, x minus pi over 4, and then over over, just over 1 factorial, so it's not over anything. Okay, so now what we're going to do, I'm going to come over here and do a little side trip. We knew that f is equal to cosine x, and actually I'm going to do a little bit of a side trip here for a minute. Since I need to get to degree 3, I know that I'm going to have to get to the third derivative, so I'm going to go ahead and do that right now. So f prime will equal negative sine x, f double prime will equal negative cosine x, and then f triple prime will equal positive sine x. All right, so I've got those at my disposal and I'm ready. Okay, so when it's asking me, first of all, f of pi over 4, we already found that it was equal to the square root of 2 over 2. Okay, and then plus the derivative was negative sine x. If I plug pi over 4 into there, sine of pi over 4 is square root of 2 over 2, but there's a negative in front of it, so this is going to be negative square root of 2 over 2, and then we'll just leave that as x minus pi over 4. We don't need to do anything with that. So this is a polynomial of order 1. Okay, so now we've got order of 2, which is going to take what we already have, because we've already gone out one order, so we don't really need to recreate that. Okay, then the next part, if I want degree 2, we're going to do the second derivative at pi over 4 times x minus pi over 4 squared all over 2 factorial. Okay, so now when we go to rewrite this, we are going to have the square root of 2 over 2 minus the square root of 2 over 2, x minus pi over 4. And then the next part, the second derivative at pi over 4. So if I plug pi over 4 into the second derivative, cosine of pi over 4 is still square root of 2 over 2. I still have a minus there. So we're going to have negative square root of 2 over 2 over times x minus pi over 4 quantity squared. And then it's going to be over 2 factorial. And if I wanted to simplify it, which I would like to do, we are going to get the square root of 2 over 2 minus square root of 2 over 2, x minus pi over 4, and then minus, if I did this, 2 factorial is actually equal to 2, so square root of 2 over 2 divided by 2 is actually square root of 2 over 4. I just multiplied this 2 by this 2, x minus pi over 4 squared. So that would be the polynomial of degree or order 2. Okay, it did say to get to 3, woohoo, so we're going to take what we already have. So square root of 2 over 2 minus the square root of 2 over 2, x minus pi over 4, minus the square root of 2 over 4, x minus pi over 4 squared. And now I get to add the next part, the order 3, which is again going to be the triple derivative of pi over 4 times x minus pi over 4 cubed all over 3 factorial. Okay, and without writing the rest of that stuff out, I'm just going to put ditto, ditto, ditto. Okay, plus. All right, the second derivative of pi over 4, the third derivative, excuse me, if I plug pi over 4 into my third derivative, the sine of pi over 4 is square root of 3 over 2, square root of 2 over 2, excuse me. Okay, 3 factorial is 3 times 2 times 1, which is 6. So if I put these two together, I'm basically going to be multiplying the 2 and the 6 together, so that's going to give me the square root of 2 over 12. I do believe if I did that right. I'm hoping I did it right here. And then I'll have x minus pi over 4 cubed for that next part. So that would be my polynomial of degree 3. What you should notice, and when I draw you an example 3, we're going to draw a picture of it. What we'll notice, the more powers we get out, the closer the actual function is going to get to the cosine, the actual polynomial. All right, question 2. F of x equals the square root of x plus 4 at a equals 0. And just to let you know, since I'm centered at 0, instead of this being a Taylor polynomial, we can actually call it a MacLaurin polynomial because it's a special type. And Mr. MacLaurin actually did develop this centered at 0. He did a lot of work with it, so he gets the credit for it. Okay, first thing that I like to do, because again, we know we need to get 0, 1, 2, and 3, I like to go ahead and find my derivatives to start with. So, and actually I'm going to give myself a little bit more room, I think, here. I'm going to put actually x plus 4 to the 1/2 power. Okay, and then when I take the derivative, I'm going to get 1/2 x plus 4 to the negative 1/2, and I'll simplify that in just a minute. But I'm going to find my derivatives first. If I do that again, I'm going to get negative 1/4 x minus 4 to the negative 3/2, and then take my derivative one more time. I'll get negative 3/2. I'm going to get negative or positive 3/8 x minus 4 to the negative 5/2. All right, and then I'm going to go ahead next to them. This would be the square root of x plus 4. This will be 1 over 2 square root of x plus 4. This will be negative 1 over 4 x. Were those pluses? Yes, they were pluses. Sorry about that, guys. X plus 4 to the 3/2 down below, and this will be 3 over 8 x plus 4 to the 5/2. So now when we go to plug things in, that will just make our life simpler. Okay, so here we go. So polynomial of degree or order 0 is just f of 0. And so this is, if we plug 0 into this formula right here, I just get 2. So that's the polynomial of order 0. Order 1 will have 2 plus f prime of 0 times x, and we don't need to put x minus anything because it would just be x minus 0. So when I do this, I'm going to get 2 plus f prime of 0. If I plug 0 in here, I will end up getting 1/4, so this will be 1/4 x. So that's my power, my degree 1 polynomial. And then if we go to get our degree 2 polynomial, we're going to have what we already started with, and then plus the second derivative at 0, x squared divided by 2 factorial. So when I go to figure this out, I'll get 2 plus 1/4 x plus, when I take the second derivative and plug in 0, 0 plus 4 is 4. 4 to the 3/2, I'll do the square root first. The square root of 4 is 2. 2 to the 3rd power is 8. 8 times 4 is 32. So this is going to be negative 1 over 32. This will be negative 1 over 32, x squared. And since 2 factorial is equal to 2, negative 1 over 32 divided by 2 is going to be negative 1 over 64, x squared. So that's my second degree. And then my third degree, we're going to have what I already had, 2 plus 1/4 x minus 1/64 x squared. And then plus the third derivative at 0, x cubed over 3 factorial. So if I go over here and plug 0 in for my third derivative, 0 plus 4 is 4. The square root of 4 is 2. 2 to the 5th power is 32. Whew, okay, 8 times 32, I don't know off the top of my head, 32 times 8, let's figure this out here, it's 256. So I'm going to have 253 over 256 for that one. And then I'm going to divide it by 3 factorial, which is actually 6. So 3 over 256, and then divided by 6, that's actually going to be 1/512th. So this will be my third order polynomial is going to be 2 plus 1/4 x minus 1/64 x squared, and then plus, it's going to be plus 1 over 512 x cubed. So again, what's going to happen, the higher power we get, the closer the polynomial is actually going to match the function. All right, we are going to do one more. I strongly encourage you to try this one on your own. Pause the video and come back and see how you do. All right, I need a first degree, a third degree, and a fifth degree this time. So what I need to do, I need to get up to the fifth derivative. So I'm going to go over here and get my derivative set. So f is equal to sine x. F prime is equal to cosine x. F double prime is equal to negative sine x. And f triple prime is equal to negative cosine x. I need to keep going. F The fourth derivative of x is equal to sine x, and the fifth derivative of x is equal to cosine x. So now I'm going to use that information. Okay, I need a first degree, so I'm going to start the first degree polynomial, and this would actually be another MacLaurin polynomial because it's centered at 0. And I'll show you again what that means to be centered at 0. Just a second here. So if I want degree 1, I need to do f of 0 plus f prime of 0 times x. So if I do that, f of 0, the sine of 0 is 0, plus f prime of 0, cosine of 0 is 1, so it will just be x. All right, so, and then P3, we're going to go all the way to 3. We're going to have x, and that got me to my first degree, so I have to add in my second degree, x squared over 2 factorial, and I also have to add in my third degree, x cubed over 3 factorial. Okay, so if we figure this out, we're going to have x plus, okay, the second derivative of 0, so go to the second derivative, plug in 0, I end up getting 0. So actually this whole part is just going to be 0. And then this part, the third derivative at 0, if I plug in cosine 0 is 1, but I get a negative, so this will be, right here, this is going to be negative 1. And then I'll have negative 1, 3 factorial 6, so I'll have negative 1/6 x cubed. So that's my third degree, and then we need to get to our fifth degree. So far we have x minus 1/6 x cubed, and then plus we have to do our fourth degree. So fourth degree at 0, x to the fourth over 4 factorial, plus the fifth degree over 5 factorial. And notice this mostly is, once you get it set up, it's just a lot of calculating, which can kind of be a pain, but we'll get there. Okay, the fourth derivative of 0, this is just going to be 0, so this whole part drops out. And then we've got the fifth degree, we're going to do cosine of 0, which is 1, and then 5 factorial, let's see, 5 times 4 is 20, times 3 is 60, times 2 is 120, times 1 is still 120, so this should be 120. So my fifth degree Taylor or MacLaurin polynomial is going to be x minus 1/6 x cubed plus 1/120th x to the fifth. So that would be my next, that would be my fifth degree polynomial. Okay, and you'll notice in the next part it says to now graph the above. So if I were to graph this, we're going to graph, if I were to graph sine x, first of all, let me just draw what sine x looks like. Sine x, if you recall, looks like this. So I'll just call that one sine x. And then if you graph p sub 1x, which is x, if you recall, just looks like that. So that's P1. You'll notice that does not really look like that function at all. Okay, now we're going to graph P3. And P3, if you type that into your calculator, x minus 1/6 x cubed, you are going to get something that looks like there a little bit more. Okay, so notice we're starting to get the curve like the sine function is going. So that was P3. That was a third degree polynomial. Now let's try P5. Okay, if we do P5, if we type into our graphing calculator x minus 1/6 x cubed plus 1/20th x to the fifth, we will get something that looks like, actually it goes a little curvier down. Okay, that would be P sub 5. Notice we're actually starting to get more of the curve going on like the sine function. So when we are trying to find a polynomial to fit that function, it usually helps us to go out many, many degrees, because the more degrees we go out, the closer the polynomial is actually going to be to the true function. So if I want to make comparisons between the two, the more powers that I go out, the better it's going to be. And I just wanted to show you one thing. This is that same thing. This is a sine function, and you'll just notice the more powers, the more degrees I go out, my function is just going to keep getting closer and closer. It looks like this one, this purple one, might be one of the highest degrees. Notice it's really just taking on the shape. It's getting closer and closer to modeling it. And I was going to mention another thing. It's centered at 0. So notice we're taking these polynomials and we're centered around this value right here. So we're we're modeling everything based on just this part of the graph. So notice it's getting closer and closer, centering around that part of the graph. So hopefully now you can create a Taylor polynomial. And if you notice we did skip example 4 and 5, you can go ahead and cross them out forever because we are not ever going to do them.